I'll be here tomorrow. I'm going to come to the couple of talks tomorrow.
So first of all, who are you?
Hi.
We'll get to you.
I'm Andrew Cushman.
And what do you do?
I'm a director in the security business unit. I'm responsible for outreach to the security community. I sit in between the Microsoft Security Response Center and the security engineering teams that are driving a security engineering process into.
And behind you is the BlueHat event or a conference.
Right.
What do you call it? An event, a conference?
It's the BlueHat conference, BlueHat Security Conference.
All right.
Microsoft puts this on twice a year.
And we grabbed an attendee, right, as he was coming out of here.
Hi.
So who are you?
I'm Mike Edwards. I'm a security program manager in the WinFS team.
Ooh. We'll come over and see WinFS sometime soon.
WinFS is going to put a database on every client desktop, so that scares the hell out of me.
Yeah.
That's my job, to be scared. And to translate that fear into action and get my team to do the work that we need to do to secure WinFS.
Yeah. So what did you learn here today?
I took a number of notes. I was taking two OneNotes at the same time. One was just a running dialogue of what he was saying, what I was thinking about it, and then I was switching over to things that keep me up at night. So there was sort of bubbling up the top issues that I need to get to my team. For example, one of the things that came up is, we're threat modeling our component services, but we're doing virtually no threat modeling of interactions between components. So we really need to threat model not just the fact that our component is secure, but when our component is used with another component through another technology, there's ways to hook those things together to make that to create vulnerabilities.
Which talk did that come out of?
That was the first one. That was David's talk.
Okay, so you want to tell the viewers who we actually saw today?
Yeah, it was David Litchfield started out. His talk was basically. I've been wanting to see David Litchfield for a long time, and that was really who got me here. Because I've read so much about him. I read his open letter to the anti-bug track community last year, where he declared that he was really worried about all data that's stored in Oracle. He really ripped Oracle apart today. We're next, though. He's not started on Yukon. He hasn't even started on Yukon yet, and he's not recommending Yukon yet either. He's recommending 2000, SQL Server 2000, and primarily because that's the database he knows. Yeah. And Oracle's just too inviting the target right now, but that'll change, especially when WinFS puts a SQL Server on every desktop.
Yeah. Now, who is David Litchfield?
A relational technology on every.
David is obviously somebody you look up to, but who is he? He's not a Microsoft employee, right?
No, he's a consultant for NGS Consulting. He's a partner in that company, and his job is to understand database security and to find vulnerabilities and to publish them. First of all, to alert the database company about the issue, to work with the company to get the issue fixed, to work with the company to increase and heighten awareness within the company of their security issues. Yeah. And he does a very effective job at that. He's very respected at that. Yeah. Very well communicating on that.
So this was a good spend of your time?
Absolutely. I wish I could have got more of my team to come. We're so crunched for time. People are so busy. But I recommended all my threat model authors to come to the talk, and I saw about half of them in there. Our penetration engineer is in there. I recognize quite a few people from SQL Server in there.
You guys film this, though, right? So that people can watch this later on?
So in addition to 500 people in the audience, we also have it streamed over the corporate network, and then it is recorded for on-demand viewing afterwards. I was surprised when the second speaker, Alexander Kornbrust, asked the audience, so how many of you guys in here work on SQL? And
half the hands were up, a little more, 2/3.
Yeah, it was more than half the hands.
Yeah. Now the audience here is Microsoft employees.
That's right.
But the people on stage are security experts from around the industry, right?
Well, there's more security experts outside Microsoft than there are inside Microsoft. We have a fair number of them here.
They are our friends. They are all our friends. We need fantastic relationships with these people. They are doing, we need to embrace them, thank them, and pay close attention to what they're saying. Yeah. And we've been doing that. We've been doing that. Other companies aren't doing it as well as we are. That's a practice that other companies will gather too. The other thing I got, Oracle keeps adopting all of our security practices 2 years after we do it. First, they pan them for a while, then they realize, oh, that's actually a good idea, and then they do it. There's another thing that I learned was all of our client databases, we need to obfuscate all of our database connection, all of our database commands, all that stuff can be easily scanned and hacked. I think the main thing I learned was I've been arguing that we have some threats where you can do arbitrary SQL against WinFS, and we're locking all those down because WinFS is not a SQL server. And there's a number of reasons why it can't be that. Security, big one. Yep. And so we have a lockdown feature that will prevent that. But the lockdown feature can be hacked by binary manipulation on the local on the box. And people some of my teammates have been arguing against me that if you can modify binaries on the box, then all bets are off. And so it's not worth dealing with. And my comeback is rootkits. People are going to install rootkits on these systems so they can get a backdoor into the box. Yep. And we're another backdoor into the operating system for that, and all the data people are putting in WinFS. And what we need to do is leverage Windows resource protection so that or other mechanisms to ensure that our binaries have not been tampered. Yep. And I'm going to escalate on that, and I'm not going to let us resolve those security threats simply because it requires binary manipulation. And I would not have known that had not come today.
That was at Alexander's.
Yeah.
That was at Alexander's talk.
Yeah.
He demonstrated how you can simply using a. Did you say this?
Yeah.
Using a hex editor.
Yeah.
Just go in and modify the table name, and then it'll load the stuff from that table.
Wow.
So anyway,
this is scary stuff.
Yeah.
Do we want customers out there to see this?
Good thing. Good thing.
Yeah. Well, thanks for spending some time and explaining what you learned, and can't wait to see WinFS.
Oh, me.
Go back and ship. Thanks, man.
So I do want to actually comment about David Litchfield. His focus over the last year has been on Oracle, and we invited him in not to come talk about Oracle, but to come talk about SQL injection. Yep. And he said, look, what I've been working on, I've been working on Oracle, but it's as applicable to SQL databases as Oracle.
Yep.
So I'm going to talk about elevation of privilege. I'm going to talk about triggers. I'm going to talk about running code, all of that. And I'm going to talk about attack surface. And I'm going to talk about the complexity of the database.
Yep.
All of that applies equally well to SQL Server as it does to Oracle.
Yep.
And the other thing that we've done, so this is the third time we've done this, and the first 2 years we had, or the first 2 times, twice a year we do it. First 2 times we had, we didn't do as good a job as we could have in actually delivering a call to action message to the developers. So this time we actually said, no, at the end of every talk, we're going to take 5 minutes, we're going to have somebody from the product team come up and reiterate the things that the developers and the engineers need to walk away from this with.
Right.
And sounds like I was pretty successful based on what Mike's going away with.
Now, BlueHat, I've heard of the BlackHat conference, which is held in Vegas and around the world.
Yeah.
That's where a lot of these security experts get together and share ideas.
Right.
What does the blue mean?
Well, BlueHat is because it's a play on BlackHat, and the Microsoft employee badges have blue background. So this is a conference for full-time employees. So we call it BlueHat instead of BlackHat. It's a little bit of a nod to them.
Well, cool.
Yeah.
Well, thanks for doing this, and
my
glad
pleasure.
to see Microsoft is bringing the security world to here to train our employees.
One of the things we do is we are a self-critical company, and we do listen. So all I'm doing is facilitating a communication channel.
Yeah.
So, and it's great to see that people are listening.
And it's worth repeating, too, if a customer or if anybody has a security vulnerability that they don't know about yet or that they're doing research on, send an email to secure@microsoft.com.
Secure@microsoft.com is the place that's monitored 24/7.
Yeah.
Yeah.
Thank you very much.
You're welcome.
So we're back here. You just pulled a speaker out, so we've...
Kev Dunn from NGS just finished his presentation to the audience. He was talking about database security. So we've had David Litchfield talk about threats. We've had Alexander Kornbrus talk about rootkits in databases. And we've got Kev talked about configuration and how do you actually get in. So what'd you think? General impressions?
General impressions of what I talked about?
No,
of the audience. Yeah, there was basically a lot of smiling faces, definitely. A lot of people realized that everything I was saying wasn't new in some ways, but it's still not being taken up. because this is essentially a way in which we break in. It has a knock-on effect to what David was talking about in terms of raising your level of compromise from low privileged user to high privileged, and what Alexander was talking about in terms of just simply hiding what you've been doing and having a rootkit in there. So I think it brought it all together pretty nicely. I finished with some stuff about Yukon, SQL Server 2005, and also about how we really need to think about our WinFS in the future when that comes in here.
We just met one of the WinFS guys who was in your talk and gave you great praise.
That's good.
The next question.
What was your talk about? Because I don't think I did a very good job of actually describing what you talked about.
Okay, well, I talked about how to break into database systems across the board from our research and our consultancy background. So we're talking about IBM's DB2, MySQL, SQL Server, Oracle, pretty much how when I go into a network I can break into any of the databases that exist there simply because of the fact that people don't patch them properly, they don't configure them properly. We had a look at how Oracle's application server makes everything's so much a bigger problem, and as I said, I rounded off with what we need to look at in Yukon in the future.
Okay.
Now, how did you get into this field? Because I don't think, like my son's 12 years old, I don't think he would wake up in the morning and go, I want to be a security researcher.
No, I actually worked for the British Ministry of Defence. I was an engineer. I started working on CAD-CAM programming. That led to C++, and then I basically had several serious security warnings from the RAF police force for breaking in and modifying certain things on the corporate environment that we were looking at. They started a brand new pen test team, and funnily enough, my name come up. I don't know why, and that's been how it's been ever since.
Wow.
So I do think that people who get into security, they just kind of end up there. That it wasn't like they set out and said, wow, this is the career, I want to go be a security researcher. It's naturally curious people who find something and go, gee, I wonder what would happen if I did this.
Yeah. Why would somebody from the outside world come to Microsoft and train Microsoft employees, other than just financial? Because I assume you're getting paid a little bit.
Well, this is like a golden opportunity in a way. I mean, this is the biggest audience I've ever spoken to, for a start. It's the people that are making decisions about how to code things, how to change the user's experience and the administrator's experience to make sure that the configuration issues that we see can no longer be an issue because it's just simply not an option to configure things insecurely. So it's great to come and talk to people like this. I'm sure there's going to be lots of people that want to talk, and it really is just an opportunity like no other to talk to such a big development and audience and hopefully get them to take on board some of the ideas.
Yep. Well, thanks for coming and helping us out.
Thank you very much.
Thanks.
Thanks.
So look at me, and we're here at the BlueHat event, I guess. And who are you? First of all,
well,
introduce yourself.
I'm Harder Flark. I'm head of research for a German company called Cybersecurity.
Wow.
And we specialize in reverse engineering tools.
That sounds fun.
It is.
That's not your average software engineering job, is it?
Not quite. It's quite math intensive as well. It's fairly algorithmic, and it's fun.
So what are you doing here at the BlueHat conference?
I was invited, and I'm giving a talk tomorrow.
Oh, and what are you talking on?
On reverse engineering Microsoft updates, basically.
So you're the guy.
doing diffing on executables, using a bit of graph theory and a little bit of math, applying that, and turning updates into exploits rapidly. That's the thing.
Since this goes public, what are you trying to teach employees? Because you're talking mostly to Microsoft employees, right?
Yeah.
But you're also talking to your fellow security researchers who are in the room as well. What are you hoping to get the audience to realize or to learn from your talk?
I don't know.
You don't know? So what are you gonna? Well, okay.
I mean, we all like cool algorithms, right? We all like clever ideas. I'm kind of hoping that I can just show up or show some fun ideas and a cool algorithm.
So you're trying to impress them.
No. Well, I was invited to come here to give a talk.
Yep.
And I just said yes, and there's no greater agenda behind it.
Okay. So. Wow. What makes a cool algorithm? Since that.
A non-obvious way to do something. And what was always nice is having a problem and then not being able to solve it, and then finding a nice abstraction for the problem and then solving it on that layer. And that's fun.
Can you give me an example of something that you've done?
All right. So one of the things within the SpinDiff tool is you have the problem that the compilers always rearrange instructions between builds for optimization purposes because they go to different pipelines of the CPU.
Yeah.
And so one of the challenges, or just a small fun hack which we used was, you want a signature for a sequence of instructions, but that signature should remain invariant if you start switching instructions around, like for all possible permutations as well. And the way we did it is very, very simple. You just assign a small prime number, a unique small prime number to each possible element in the sequence. And they multiply along the sequence. Because A times B is B times A, the result of that multiplication is the same no matter how you rearrange that sequence, as long as the number of items of each stay the same. And that's fun, but there's more to it.
I'm sure there is. How did you get into this world? I mean,
it started. Well, my brother was doing copy protection work back. Like, he's 6 years older than me. And when I was 8 or 9, I asked my bigger brother how you crack software, like copy protections. And he told me you just invert a jump. It's fairly easy. And I didn't really
what do you mean by inverted jump?
Yeah, you have a branch instruction in the CPU, and there's a test. Do you have the license or not? Yes, no. And that was back in the 80s or very early 80s. And I didn't really know what a jump is. And then a few years later, when I was 16, I went to the States for a year of a high school exchange, and I ended up in Minnesota and had high-speed internet access and not much else to do, and bought myself a book, figured out what a jump was, and started learning about reverse engineering. And then very quickly started to work for a company that creates copy protections, and then drifted from there to security.
Wow. That's really, it's a lot of fun.
Oh, yeah.
What's the conference been like here? What have you been learning? Have you been learning or meeting cool people? Or?
Well, I'm meeting a few friends that I haven't seen in a while. That's always fun. Also, Microsoft has hired a bunch of good talent over the last years, so it's always good to catch up with them again. The SWI team is full of very bright people. And, yeah.
How's Microsoft's approach to security been changing over the years?
I don't know.
Oh, yeah.
Well, I'm not interacting with Microsoft all that much, right?
Okay.
And Microsoft takes security very seriously, and they are trying to be very nice with the security researchers, so I guess everything's good.
Thank you for spending some time.
No problem.
Good luck with your talk tomorrow.
Thanks.
So who are you?
My name is H.D. Moore. I'm founder of the Metasploit project. I'm currently working at a company called Breaking Point Systems, where I design security test hardware.
Okay. What was the project you said?
The Metasploit project.
And what is that?
It's a collection of kind of enthusiasts and researchers who release exploit tools and security research tools. That's an interesting
community that you built. Why are you here? And we're at the BlueHat
conference. They invited me, of course, so I showed up. But, they got free food, they got free drinks. That's about it.
That's why I work here.
That's fun. Actually, the coolest thing about presenting to Microsoft is they're one of the few people you can present to who are actually capable of fixing the things you present. Yeah. There's not many groups you can go actually find the person who wrote the code and say, hey, why did you do it this way? Yeah. Like, a lot of times people do security research, they don't really understand the code they're looking at that well. They just try to look for vulnerabilities. And a lot of times they're wrong. They'll release exploits saying, oh, not really exploits, but advisories saying, well, this code looks like it does this, this, and this, and that's a security vulnerability. But they don't know that, 3 levels below that does something else. So, for instance, about 5 minutes ago, I was able to talk to the guy who runs ASP.NET development and say, hey, I found all these strange things when I was reverse engineering all of these ASP.NET 2.0. Is this a bug? Is this a bug? Is this a bug? And basically 9 out of 10 weren't, but I got a good one, so it worked out great. Excellent. It's nice to be able to talk to actual developers and figure out whether what I'm researching is even worth their time, whether it's useful, and if there's an impact, what that impact actually is.
Yep. Why do security research?
It's fun. There's nothing more.
What's fun about it? I mean,
well, imagine
to most people who watch my videos are like, huh?
So you have two perspectives.
Playing Halo is fun.
Developers, when you're developing a project, you start off and you build things up piece by piece by piece. When you're breaking a project, it's much better. You find one tiny little crack in a project, and then you stuff everything you possibly can into it. So it's like, okay, we found a small overflow here where you can override a function pointer. Now let's take all this, shellcode, these payloads, and stuff them in here. Now let's use that to load the next stage, and the next stage, and the next stage. And we've actually automated that with Metasploit projects to the point where you can use any vulnerability to basically immediately take over the desktop of the system without installing any software or writing anything to the hard drive. So literally, you can take a DCOM exploit a system with it, and 2 seconds later, have your mouse on their desktop, moving around and taking over their desktop without an antivirus or anything else being able to catch that because it's all in memory.
Wow.
So kind of an example of where we've taken kind of exploit technology, and the biggest talk I'm doing this year is about Metasploit 3.0, kind of where we're going with that, and the new features, the new designs, and how we're really building a development environment for security tools and exploits, not so much an exploit tool itself.
Right. To the untrained ear eye watching this, that might sound a little evil. You guys are trying to break into things, right? Or trying to break things.
Right.
Defend your craft. Why is that? Somebody who doesn't understand what you do, why is that important? Why is this endeavor important to the world, I guess?
There's different approaches to it. When we first started working on the project, the problem at the time was that lots of vulnerabilities were being reported, but if an exploit wasn't available for the vulnerability, nobody really took much notice of it. They said, oh, look, another RPC vulnerability that causes a crash. Who cares? On to the next thing. And then Blaster came out. And you had these gaps where you had a vulnerability was disclosed, and then a month later you have a worm hitting that vulnerability. And in the meantime, no one would really, the awareness wasn't there. Excuse me, that awareness has changed because these days when a new vulnerability comes out, an hour and a half, 2 hours later, 2 days later, an exploit comes out for it that demonstrates exactly what the impact of the vulnerability is. And the problem is exploits take a long time to write. I mean, it's not easy code. You have to figure out, okay, how does this application work? How can I manipulate the program in a way that causes my code to run? And sure, there's some easy cases like Stack Overflows and whatnot, but there's also some really oddball cases like the wins bug, where basically you're writing a pointer to memory, you're dereferencing a structure in memory where the server leaks back one address, you send that address back, and it's not really a standard Stack Overflow. It's just weird memory corruption flaws.
Right.
That takes a lot of time, and once you have an exploit, the exploit is only as good as how much time you put into it. Yeah. So if you release an exploit in C or another language like that, or a standalone exploit, then sure, you can say, okay, now I can launch my bind shell payload or my reverse connect payload. But what if the system you're attacking runs like Cisco Security Agent, and that shellcode doesn't work? How do you demonstrate to your boss that it's still a flaw you should patch, even though you have this other defensive solution installed? Well, it's easy to modify your shellcode to bypass some of these restrictions and filters, do things like write out a file and execute that file, or otherwise, add a user account. But unless you have complete control of your exploits and be able to modify the payloads and all these nifty things about them, it's hard to actually demonstrate that it's still a risk, even though you have these other solutions in place.
Yep.
So what Metasploit does, it basically gives you a framework to not only launch exploits, but to build and manipulate them, change every possible option, use payloads, change things out, modify them so that they bypass this system and that system, or below pass this IPS. And it's really a great way to test not only how well does your defensive solution work, but demonstrate to your boss why you should patch something, and why do you have to bring the server offline for 2 days to install this set of patches.
Yeah.
So that's more for administrative justification, for proving your point when it comes to yes, this vulnerability is actually an issue, and it's fun.
Yep. Now you know how things leak out of here, right?
Yeah, same
you
thing.
got 3,000 people who know something.
Microsoft bugs is most of them are known to the security researchers before they're even reported to Microsoft.
Yeah.
Someone says, hey, I found a new bug. Oh, yeah, what is it? Okay. Because a lot of people working in the same areas all the time, so we keep in touch. I'm like, okay, I'm working on, this SMB flaw, or I'm working on this flaw in Internet Explorer. You contact your friends, are you doing something similar? Like, yeah, I just reported 3 like this.
Yeah.
And now they know, hey, you reported 3 like this. I'm not going to investigate that because I'm already wasting my time.
Yeah.
But a lot of times, one of the reasons you see exploits come out so quickly after vulnerabilities are disclosed is exploits were written way before the vulnerabilities was given to Microsoft, or a week or two after that. Anyway, so Metasploit's in a weird position now where we'll actually receive vulnerability reports months before they actually become public, because the people writing them need to be able to demonstrate they're exploitable to be able to sell them to somebody or do whatever they do with these vulnerabilities. So someone will say, hey, I found this bug, I need help writing an exploit for it. And our deal is, okay, we're going to write an exploit for it. We won't release it until it becomes public, but we're going to release it pretty soon afterwards. And we just want early access basically to save ourselves time when it does come out. So a vulnerability will come out, we'll release our exploit for it, and everyone's like, hey, wow, you guys wrote it really quick. We're like, yeah, I wrote it really quick 3 months ago. And so when you're seeing kind of the diminishing timelines, a lot of that is because people are already ready to go before the one's even disclosed.
Right. For the Microsoft customer, what does this whole process mean, other than a little bit or a lot of pain, while things are not patched, not where there are security holes in our product? What does it mean at the end of the day? Maybe 10 years from now, does it mean
no different now than it will be later?
What's that?
It's really no different. the thing is, every operating system, every large application is moving to auto updates for security updates, like automatically downloading and installing security updates. What that means is, from the attacker's point of view, your targets are people who don't have online updates for one reason or another, or people running old operating systems, or using vulnerabilities that aren't currently disclosed, like that no one knows about. So the value of a known vulnerability and running an exploit for it is going to diminish rapidly as firewalls come up. SP2 is a great example. If you're looking at the wormability of a vulnerability, which isn't really a term, but you can make one up, like Blaster is a great example, because the ISPs allowed access to port 135, which pen testers have known for years. Because if you're doing a pen test, a lot of times the ISP will block 139, 445, but you can do a lot of the same functionality over the RPC port. Like you can enumerate users and things like that over RPC. So it was a wake-up call for everybody saying, oh wow, if you have the other port open, you can still do things to that port too. But as the firewalls get put in place, as the NX chip stuff is actually getting applied and actually affects all applications of the system and not just the ones that are opt-in right now in the default settings, you're going to see the usefulness of exploits, the usefulness of new vulnerabilities to attackers are going to start diminishing. There's also the human element, so as long as someone can still double-click a zip file and then execute an exe inside after typing in a password, which, what virus is that? There's one where the user actually had to type in a password to a zip file to extract an exe to run it before it would actually run on their system.
Yeah.
And it worked well enough that the virus is still propagating. So.
Yeah. Is there ever going to be a day when there's a perfect OS that can't be exploited?
Probably, but it's probably not going to do very much.
Why is that?
Because if it can't be exploited, then you can't really use it either. The second, you have two classes of bugs. You got programming errors, you got behavior errors, where the user does something that they think is going to be a safe operation, which isn't. Good examples are the drag and drop flaws in Internet Explorer. These issues all depend on the fact that you can get a user to click on something and drag it someplace else and let go of it. And how often do you go to a web page and drag and drop something from one spot to another? But if you can tell the user, hey, to win $50 in a free game, drag the monkey into the pit of scorpions, they're going to do that, and then right before that, monkey goes to the pit of scorpions, you're going to flip that page out with like the shell view, and then they're going to drop a scheduled task under the scheduled task scheduler, and then your code's going to run. And there's no vulnerability there besides the fact that you can trick the user. And those are never going to go away no matter how we look at it.
Interesting. Well, thanks for spending a little bit of time.
No problem. Thanks.
Thank you. So you got your talking points here?
Yeah. I'm not PR trained now. Looking directly at the camera this time. Last time I did
there's nothing in your hands other than a candy wrapper, right?
Last time I did the Channel 9 videos, I got some feedback from the security community. And this is the way it works. Security community gives Microsoft some feedback. Microsoft listens, does a little better job.
Yep.
So last time, Adam actually blogged that, it looked like Andrew's got some great PR training, and that, man, you should see that Microsoft PR machine at work. He keeps looking down over here to the left. Oh yeah, there it is talking about it. Yeah, sure. He didn't, although he might have, said, wow, you can just about see the puppet strings back there.
Are there any?
So I thought this time around I'd actually do Adam a favor and put him on Channel 9.
Oh, why? Thank you.
Yeah, I'm sure so. So what do you do?
Well, I'm...
Other than giving Microsoft guys a hard time for PR gaps.
I'm CTO of a company called Reflective. We build source code analysis, help people find bugs in their software before they ship.
Yeah.
And I also have a blog, which I write, emergentchaos.com.
Oh, I've heard of that.
Oh, cool.
So, I always know people by their blog name, not by their real name.
And so actually, what Andrew didn't tell you is that when I did the post about him, it started out commenting on the looking down bit, but it ended up being an interesting post, I think, on redaction issues of when you have data and how you cut it into smaller pieces. Okay. So I wasn't just trying to laugh.
And that's okay. It was a point well taken anyways, and one that my PR team didn't actually deliver to me.
So, what are some of the issues around redaction since you brought that up?
Well, it turns out to be very hard with these modern data formats to figure out what's in a file. And what happened was I took the little video thing, I took a screen capture, and then I moved the screen capture and saw all of this other data in the PDF screen capture that I'd taken. When I thought I'd cropped it down to a little bit of Andrew's face like that. And you could read my email, you could see some IM windows, And I was aware that these things happened, but it was still sort of a shock to actually.
A competitor of ours, and we won't name them, this week had something like that where they put a PowerPoint slide presentation out, and it had a few confidential notes that were still located in the document that they hadn't cleaned out. It caused them a little bit of trouble this week.
But it's really hard. What are the tools that you should be using to look at? Here's this file format. Here's everything that's in the file.
Yeah.
So I talked about that a little bit and made fun of Andrew a little bit.
Yeah.
But the usability issues, I think, are really, really interesting because these things keep happening. There have been secret documents that come out.
Yeah.
There have been documents released early. There have been documents that have contained all sorts of embarrassing things. And
see, I just write about my embarrassing things on my blog, so nobody can find secrets.
No secrets here, yeah.
Wasn't it Madonna who said, exploit yourself before anybody else does? So, what are you speaking on here?
I'm actually speaking on the closing panel about, is it future trends in security?
Ooh, what are the future trends?
Well, I think there's a fascinating thing where since ChoicePoint bungled a revelation that they had some hackers, they had some con men take data from them. There are these laws in place now in 22 different states that require that you talk about a breach of confidentiality that involves customer data.
Yeah.
And I think that that's changing the way people look at these things. When it used to be you got broken into, it was a big deal. Now we're seeing, lots of people get broken into every week.
Yeah.
Lots of laptops are stolen, lots of tapes are taken full of data, or the tape goes missing. And
none of that gets reported.
How it's getting reported, but also our ability to analyze it.
Yeah.
Because now we don't just have the occasional bit of data, we have, I've got 200 incidents listed in a breach category on my blog. The Privacy Rights Clearinghouse has additional ones, attrition.org has them. And so we're getting to the point where we can actually analyze trends. What's happening? Is it educational institutions? Is it companies? Is it government bodies? What sort of data is being taken away? Yeah. And I think that the shift from your data was stolen, oh my God, we can't talk about this, let's sweep it under the rug, to we've now seen in the Bahamas, in the United Kingdom, where there are no laws requiring people to disclose that the breach happened. The disclosures are happening anyway because there's a shift in the way the expectations and the perceptions. And I think it's very important because if you can talk about these things more forthrightly instead of everyone tearing their hair out and being all upset, and yes, there's good reason to be upset, but we also have to study these, see what security mechanisms are in place, what security mechanisms aren't in place, what can we learn from these breaches, rather than, you made a mistake, that's bad.
Yeah.
Right? And one of the things that I think Microsoft has done a really good job on over the last 4 years is you've been honest with yourselves about what mistakes have been made.
Yeah.
You've institutionalized learning processes. You've got things like BlueHat here where you're calling in outsiders to come talk to your developers.
Yeah.
And maybe we'll see some similar things happening in the breach disclosure world where people will talk about what's happening, we'll institutionalize some learning, and a few years from now we'll be doing better.
Yeah. Well, thank you for coming to Microsoft and
thank you.
Helping us get a clue on security, right?
Well, it's fun to be here, so I'm enjoying myself.
Thank you.
Alrighty.
Cool. Where did Andrew go?
Andrew.
So what's up, man? So who's next?
Alexander Kornbrust.
Alexander. So how are you doing? Thank you.
Hi, fine.
So we're at the BlueHat conference, walking around here in the lobby. So who are you, other than Alexander Kornbrust?
Okay, my name is Alexander Kornbrust. I'm the CEO of Red Hat Security, and our company is specialized in Oracle security.
Okay. Now, why does an Oracle security expert come to a Microsoft?
Because I also do a lot of generic database stuff.
Okay.
And last year I presented a paper on database rootkits, how to migrate the concept of rootkits from the operating system world to the database.
Explain to my viewers who might not be up to date, what is a rootkit?
Okay, a rootkit is normally used to hide traces of a hacker after he broke into a system. Okay. So, an informal definition, a user hides files and operating system accounts and this. So you can hide processes and this stuff. Sony, for example, used the rootkit to hide the presence of a software which protects their music on the system.
Okay.
And in my presentation, I showed that a database is a kind of operating system. So all the concepts which are known from the operating systems, like viruses and rootkits, are also possible on databases, because everything which is available on the operating system is also available on the database. You have users, you have views, and I showed with simple modifications how to create invisible users.
Wow. And what does that let a security researcher do when you're an invisible? What does that mean to the system?
Okay. This means a normal administrator does not see this user, so it disappears from all administration tools. It's not shown that the user is available.
So somebody can be looking around your data and not be detected. There's no, what do you call it, report or...
Correct.
What do you call it?
So
a log. There's no log showing that this guy was in your database.
Correct, depending how deep you do this modification.
Okay.
And it's a perfect backdoor to install into a database. And this concept is platform generic, so it affects all relational databases and repository-based systems. And that's why I'm...
Now, to do that, do you have to have access to the machine itself?
Yes.
Okay.
But very often, it's...
Employees certainly have access, right? So they could put their own backdoor in, so when they get fired, they can go and still look around the data without anybody detecting that, right?
That's correct. And,
wow, that's
and nowadays, it's a big question, how can you guarantee that your system is not tampered? For example, you are a new DBA in the database, or you are insourcing your outsourced databases. How can you guarantee that these databases are not tampered or backdoored?
Yeah.
And this is a quite new concept, so there are no tools at the moment available. But Microsoft did a good job. They introduced some anti-rootkit technologies in SQL Server 2005, which is a very good job. So it's not so easy to implement these concepts in SQL Server. It's much more easier and more powerful in Oracle.
Okay. Interesting. What can customers do who have these databases? Is there anything that they can do to make sure that they weren't backdoored, or?
So the generic thing: harden your database, apply the latest security patches.
How's that?
Then they should create baselines of the database objects.
And what do you mean by that?
So you create checksums from different database objects, like views and packages and procedures.
Okay.
So if an external hacker or an employee modifies some of the database objects, you are able to catch this by comparing checksums.
Interesting.
And from the developer point of view, they can make their applications more secure if they don't trust views, because a view is a layer on top of a table.
Yep.
But this abstraction layer has no security functionality.
Okay.
So everybody in the system with sufficient privileges can modify a view.
Got it.
So if you are dealing with critical objects like processes and jobs, you shouldn't trust views.
Okay.
It's better to use base tables even if there are problems with new versions, because tables are changing from time to time and from version to version.
Got it. Well, thanks for spending some time giving us a little look into your world.
Okay.
Thanks.